We are doing different types of analysis using the level of service concept. Yesterday we did a couple of examples, one for freeways, one for multi-highways. But both of them were related to operational analysis. We were finding out level of service. Today we will start with an example which is related to design of highways, design of freeways. And this example we will find out the number of lanes. Okay, we'll find out the number of lanes for a given level of service. Okay, so we want to design a freeway. Okay, we should have a level of service of C. Okay, and how many lanes should I provide to give this much level of service? Okay, the first step is always to find out the free flow speed. The first step is to always find out the free flow speed. The equation for free flow speed is this. Okay, this is the equation to find out the free flow speed. Okay, now here I have a couple of factors. The first one is the factor for lane width, the second one factor for lateral clearance. Okay, now look at the question. Tell me, is the lane width given? Did they give us the lane width? No? Yeah, maybe they gave it in the iPad.
I cannot see.
You can see it?
No.
And you used to sit in the last row.
I wear my contact lenses. Now I've been told I contact.
Okay. Second factor is for lateral clearance. Is the lateral clearance given?
We can find the inwards from table or we cannot.
Yes, you will find inward on the table in the exam. You will find it. You still get 0. Yes. Is the lateral clearance given? Is the lateral clearance given? No. Okay. Why is this not given? Because it's design. Okay. I can give you if the highway is there. I am designing the highway. Got it? Clear? Okay. We can still fix it for a design problem as that. We can still fix it. Okay. Somebody can tell me, no, you have to put the lane width 12 feet. You have to put the lane width 13 feet. We can do it. Okay. But if it is not given, it makes sense, right? Because the highway is not there. Okay or not? Okay. If I ask you for level of service, there is the highway, Sheikh Khalifa bin Salman highway, find out level of service. Okay. And then I don't give you lane width. Does it make sense? No, because the highway is there. Why don't we go and check the lane width then? Okay. But in this problem, it makes sense. The highway is not there. We can play around with the value. Okay. If the highway was there, the value is known. Okay. So in this case, we don't know it, and we will fix the value. Okay. We'll come back to it. This is total ram density, which is given 0.5. Okay. So this is the value which is given. I will go there. I put the value. Okay. Now I will go to the tables which have the factors for lane width and lateral clearance. And I will use those tables to fix the values. Okay, now you can see here the highest value is how much? The highest value of the lane width is how much? 12. Okay. More lane width is good or bad? Good, right? Okay. if I'm going to design, I'll design for the best, right? I'll design for the best. Okay? So best is what? 12. 12 or more, right? Okay? So if I take the best value, the factor becomes how much? 0. Okay? So since I'm doing the design, I'll pick the best value for my design, which makes the factor 0. Okay? Same thing for the letter clearance. Okay, same thing for the lateral clearance. Okay, having more clearance is good, so I pick the best value. Okay, when I pick the best value, the factor becomes 0. Okay, give me the free flow speed now. How much free flow speed? You forget the contact, you have brought the iPad again. Yes.
Uh, 73.6.
When you calculate it. See? Sure.
I don't have calculator on my iPad.
Throw it up. 73.6, right? Okay. Okay, clear up to now? This is the first step. Always the first step is to find out the free flow speed. If it is not given, you calculate it. Okay? The second step is to find out the factor for heavy vehicles. Okay? The second step is to find out the factor for heavy vehicles. Okay? For finding out the factor of heavy vehicles, I need to know percentage of heavy vehicles and I need to know the terrain. Okay, how much is the percentage of, well, this one here. What is the percentage of heavy vehicles? 15%. Okay. What did they say about the terrain? The terrain is what type? Level, right? But did they stop here? No. They are saying, because we are designing the whole highway, right? So the whole highway may not have the same terrain. It's possible, right? Okay, it is possible. You are designing a highway, it could be 10 miles long. And this 10 miles, the terrain may not remain the same. Okay, so we have some terrain which is on the level, and then we have some terrain which has a gradient of 4.5%. Okay, the one which is level, it is level, obviously, you don't have to do anything. The one which has a gradient, we need the length as well. Okay, so length is 2 months. Got it? Clear? For level and rolling, I don't need to know the length because the factor does not depend upon the length. But for the gradient, I need to know the length as well. Okay? Clear or not? Sure? Okay. Now, yes. This is 4.5% plus, right? Plus means what? Up. Okay. If one direction is up, the other direction will be down. Should we design only one direction? No, we should design both directions, right? Okay. So now we have 3 conditions basically, not 2, 3. One is level. Both directions are level. The other condition is 4.5% going up. The next condition is 4.5% going down. Clear? Got it? 3 conditions? Okay. Now, this is the equation for the heavy vehicle adjustment factor. Okay, I need percentage of heavy vehicles. How much was it? 15%, right? Okay, then I need the factor, but the factor changes according to terrain conditions. Okay, we have how many terrain conditions? 3. So there should be 3 factors. 3 factors mean FH will have 3 values. Okay, the first condition is the level terrain. For level terrain, the factor is 2, right? Okay. So this gives me how much? 0.87. Okay. Then the next condition was 4.5% upward and downward. Okay. Now I need to check what is the percentage of single unit trucks and trailer trucks. It's written in the question. How much is it? 30 is what? 30 is single unit trucks, right? So this one. Okay. Everybody with me up till now? Even you. You are good at lying. Okay. 4.5% rating. Okay. This one. Okay. My length 2 miles. Which is, now what did I say about this one? I don't have 2 here. There was something like this yesterday as well. There was something like this in the spot speed case Z table. So what do we? Yes, -1. Yes, -1. Yes, yes. -1. You will have 100, and I will do -1. 0. Yes.
Values will not change.
Values will not change. Okay, we pick the last one. We pick the last one. Okay, but I have 15% trucks. Okay, so I'll pick the last one from this column. Okay, so 4.5% gradient. My length is 2 miles more than this, and my trucks are 15%. So my value is 3.1. Alright? Okay, so in that equation, I will now replace the factor with 3.11. 0.76. Okay, so instead of 2, it will be 3.11. Clear or not? Everybody with me? Okay, what did we do? Upward or downward? Which one? Up. We did the upward, right? Okay, for downward, I have to look on the negative side, right? I have the same problem on the negative side. See, the gradient doesn't go up to -4.5. It only goes up to -2. Okay? Clear? Okay. Okay. The length again, same thing. Doesn't go up to 2. It goes up to 1.5. Okay, so I pick the value from here, okay, and my percentage of trucks is 15%. So the value is 2.04. Okay, if you go there, you will see in the last thing the value stop changing. Okay, so this is an indication. After this, the value will remain the same. Okay, so now my value is 2.04. So instead of 2 here, I will put 2.04. Okay, will it make much difference? It was 2 here, right? Now you put 2.04. Will it make much difference to the value? It was almost the same, right? Okay, so we can take the same for downward as well. The same value for downward as well. You want to go ahead. But I'm just saying, if you calculate it, we are putting instead of 2.04, so you are only making a difference of 0.04. 86 and we have 87, right? And this 87 was also 0.86 something. Right or wrong? Okay, so there is not much difference in the value. But if you want to keep it, I can keep it, no problem. Okay, but that means that we have to do everything with 3 values. Okay, clear or not? Okay, right now I'll just say that it is the same as level. Okay, because of the value. The values are very close, I am keeping it same. Okay. Start off. Away. All of you should have copies with you. At least I know that we are live. Okay. This was the second step. Okay. First step was what? Find out P plus. Second step, find out FHV. We have three values, and two of them are very close to each other, so I combine them. Okay. Okay. Now the third step, we have this equation. We are finding out number of lanes. Remember, we are finding out number of lanes. So we are doing this analysis, design analysis. I'm trying to find out n here. Okay. Now the first value DDHV, design volume, is given in the question. Design value, there is a value in the question. Okay. Then I have peak hour factor. Peak hour factor, there is a value given in the question. Okay or not? Okay. These values are given. FHV, we have it now, right? We have two values. Okay. MSF. Okay. MSF is maximum service flow rate. And with that you see a subscript I. Okay. I means the level of service I want. That's why I. Because I want. Okay. So in the case of this question, how much level of service they are asking for? C. Okay. So what is the maximum service flow rate for C? Okay. For that we have to plot the graph. For that we have to plot the graph. You have to plot the graph for your term projects as well. Okay. So I will explain the procedure. Pay attention. Okay. First thing you will do is okay, we will okay, let me go there. Okay, we want a graph like this. Okay, we want a graph like this. This is something which you have to plot for your term projects as well. Okay, you will start from free flow speed. Your first point is free flow speed. Okay, y-axis speed, x-axis flow rate. Okay, on my y-axis the first point is free flow speed. What is the free flow speed? This much. Okay, so I know the first point. Clear? Okay. Next thing is we have to draw a straight line up to breakpoint. From free flow speed, I will draw a straight line up to my breakpoint. Okay. What is my breakpoint? For breakpoint, I have an equation. Okay. Now I only need the free flow speed here, right? Okay, you already know the free flow speed. How much is the breakpoint? How much is it? 1.056. 1.056. Any problem? Clear? Everybody clear? Okay. What was CAF? Capacity adjustment factor. What is capacity adjustment factor? 2000. What is capacity adjustment factor?
Oh, I didn't.
Do I have capacity adjustment factor?
No, no need, because it's
No need?
You
Sure?
don't need it.
Sure?
You need it, actually.
I don't know, I'm asking you. You guys said you don't have any problem, right? Yes. He is saying no need. Is there any kind of capacity adjustment factor? Yes. Yes. Is there any capacity adjustment factor? No? No?
You have.
Is there any capacity adjustment factor? No? Yes. He is the one who gave the value. Don't trust him. He may have given the wrong value. Yes. Is there any capacity adjustment factor? See, I asked you, do you have any problem? You said no. Now I'm asking you, there is a factor in the equation. Do we have the factor? You don't know. Is there a problem or not? Not tell me. Huh? Is there a problem? Not with the question. With you guys. I'm asking with you guys. Okay, I'm asking about you. Is there a factor in the equation? Is there a factor in the equation? Is there a value in the equation? There is, right? Do you know what this value is? Anybody know what this value is apart from this guy? Anybody else? Do you know what this value is? So is there a problem with you guys or not? There is. So when I ask something, when I'm asking you, is there a problem? Don't do this. Ask me, Dr. what is here? Then I will tell you. Right or wrong? Okay. I'm telling you, I'm asking you, is there any problem? I'm telling you what is your problem. You should tell me what is your problem. Right or wrong? Okay. Everybody agrees? We see it next time. Okay. So, going back to the graph, we are trying to plot the graph. Okay, so from here, free flow speed, I go up to my break point. What is my break point? This way. Okay, so from here up to 1056, somewhere here there will be a straight line. Okay, I start from here 73.6, I'll go forward up to the break point, which is 1056. There will be a straight line. Okay, after this I have to draw a curve, and the last point of the curve is capacity. The first point is the break point, the last point is the capacity. Okay, so the equation for capacity is also given. Okay, this is the equation for capacity. Tell me what is the capacity of this freeway. Tell me. How much?
2,400.
2,400. Exactly. 2,400 exactly. How much is the equation giving you? 2536. Yes. Okay. The equation gives you 2536. But I cannot accept this value because there is a limit. Okay. The value from the equation is whatever it is. But it should not be above this limit. Okay. If it was 2336, I will take it. But now if it is 2536, I cannot take it. I will take this one. Clear? So this is why my capacity is 2,400. Okay, not because of the equation, because of the limit. Clear or not? Okay. Moving forward. So this gives me the last point on the graph. Okay, I'll explain it from here because the equations are here. Okay, this gives me the last point on the graph. Okay, so I have the first point, which is the free flow speed. I have this intermediate point, which is my break point, and I have the last point, which is my capacity. Now capacity is what? The x value or the y value? This value is what? On the x-axis or the y-axis? X-axis, right? So I still don't know the y value, right? I still don't know the y value. Okay. So for this graph, the y value is what? Speed, right? For this curve, the speed comes from this equation. Okay. For this curve, the speed comes from this equation. Okay. What do I need here? I need free flow speed. I know it. I need capacity. I found it. I need critical density. The value is given. It's according to the highway capacity value. Okay. What else do I need? I need the x value. Vp means the x value. I'm finding out here, right? Okay. So my x value is same as capacity. The end of the graph, the x value is how much? Capacity. Clear? So this is capacity, breakpoint I know, critical density is here, and so on and so forth. So I can find out the value of speed when I reach capacity. Okay, this will become the last point of the graph. The x value equals to capacity and the y value comes from here. Okay or not? Okay. So the graph starts from free flow speed, goes to breakpoint, from breakpoint it goes to capacity. Okay. Now if I give you two points, if I give you 2 points on the graph, how will you join them? A straight line or curve? Straight line, right? We join them with a straight line. Okay. Do I need a straight line here or a curve? What is this? It's a curve, right? Okay. So 2 points are not enough. I need more points. I need more points. Okay. Now to draw the points on the graph, I need x and y axis, right? I need the x value and the y value. Okay. Y value, there's an equation. X value, Vp, right? Correct. Okay. Now I can try, because I just want the points, right? I just want some points between capacity and breakpoint. Okay. So I know it will start from breakpoint and it should end at capacity. So between these two, I can try any point, right? Any point between them is on the curve, right? Any point after 1056 up to 2400 is on the graph, on the curve. Okay. So I can put, for example, just giving an example, I can put 1500 here, right? It's between the 2 points, right? And I can get the y value. Okay. I can put 2000 here. Okay. 2000 is still between the 2 points, right? And I can get the y value. Okay. Can I put 2600? No, because it's outside the curve now. Can I put 1000 here? Can I put 1000 here? No, because it's before the breakpoint. Got it? Okay. So the points which you are assuming, the Vp value which you are assuming, 1500, 2000, whatever, this becomes your x value, right? This becomes your x value. And the other one which you will get from the equation becomes your y value. Okay. Clear? Clear or not? You have to plot this graph for your term projects as well. Pay attention. Okay. Okay. Free flow speed, breakpoint, capacity. What is the value at capacity comes from the equation. Okay. Then you select a point here, select a point here. Okay. For these 2 points, you will pick the x value from that any value between the 2 points, and the y value will come from the equation. Once you have the x and y value, you will plot these points and join them from breakpoint to capacity. Okay? Clear? Huh? Everybody? Okay. So once the graph is done, now I need to make the lines which will indicate my level of service. Okay? I need to make these diagonal lines. You see the dotted diagonal lines, right? I need to plot them to show where is my level of service. Okay? In the question, they are asking for level of service C, and they are saying D is also at C. Okay, fine. Okay. So in the question, they are saying we will do it for C, but D is also fine. So I need to make two lines, one for C and one for D. Okay? So I will find out the density for C and D, which is given in the highway capacity manual. Okay. The density for C is 26. The density for D is 35. Okay. Now density is flow rate upon speed. Density is flow rate upon speed. Okay, so my density at C is 26. Okay, and this is flow rate upon speed. Where is flow rate? Where is speed? So flow rate upon speed becomes the tangent theta, right? Flow rate upon speed becomes the tangent theta, x upon y. Okay or not? Okay. So my tangent theta is 26. So how much will be the theta? Somebody. If tangent theta is 26, then how much is the theta? Huh? How much? Okay, 0.03 means this is my slope. Okay, this is my angle now. Okay, my angle is 0.03. Sure. Is this correct? Check it, check it. How much is the theta? The tangent theta is 26. How much is the theta? 0.48. Tan inverse of 26, right? 10 inverse of 26.
This one.
87.8.
See? Like 0.48, 0.03, and it is correct. See where people are going.
You told me use the calculator 5. I don't like it.
What?
Calculator 5.
No, no, I said throw it. I didn't say use it. I told them to use it. No, I said throw it. Okay. You throw it, I will pick it up. I will give it to my daughters. They can use without calculator. They don't mind. Okay. They just want cartoons. It's good for that. How much was it? 80?
87.8.
87.8. Okay, so this becomes my angle. 0.03 cannot, 0.03 and 0.4 you cannot even see the angle then. Okay, so make sense of something. Okay, this is my angle. Okay, now tangent theta is y upon x, right? Tangent theta is y upon x. Okay, so I did what? Flow rate upon speed, right? So flow rate becomes my y and this becomes my x. So this angle is from the x, from the speed, from this axis. This 87.8 is from this axis. Okay. Any questions? Everything is clear? Huh? Okay. For D, this was 35, right? The maximum density is 35. Okay. So I will do the tangent theta for, or tangent inverse of 35. How much is that? 88.4? Tan inverse of 35. Okay. So for this line, the angle is 87.8. For this line, the angle is 88.4. Okay. The curve is plotted, the lines are plotted. Wherever they are intersecting each other, this is your maximum service flow rate. Where the line is intersecting the curve, this is your maximum service flow rate. Okay, got it? Clear? Okay, for your term projects, you have to draw the curve, you have to draw the lines as well, and all of them, A, B, C, D, and E. You can do F as well, no problem. I don't mind. Okay, clear? Any questions? Okay. Now remember the equation for number of lanes. Okay, this is the equation for number of lanes. DDHV given in the question 2700. Peak hour factor given in the question 0.85. Okay. Now what is this 17847? This is coming from this intersection point. So once you draw the line and the line for, once you draw the curve and the line for level of service C, then the intersection point gives you the maximum service flow rate. Okay. So for C, it is maximum service flow rate 1747. Okay. What was this? This was FHV, factor for heavy vehicles. Okay. We have three terrain conditions: level, upward, downward. Okay. So this is for level, this is for upward, and downward was same as a level. Okay, with a very small difference. Okay. So you can see here. Now all the values are known. Number of lanes for this case is 2 point something. Here it is 2 point something. Here it is 2 point something. Okay, so we took all the three values. Even if there was a small difference, we did not make it same here in the solution. It is given for each one of them separately. Okay. Now can I give 2.11 lanes? Can I give 2.39 lanes? You can give this. No? You will not? Sure? Huh? How many lanes? 3, right? In all cases you will give how many? 3 lanes. Okay. Clear? If one of them was 1 point something something and the other one was 2 point something something, then we can change. We can think about a change. Okay. 1 point something something can be 2 lanes. Okay. Can I give 2 lanes? Can I give, it's 2.09 very close, right? 2.09, 2.11 is very close to 2, right? Why should I give 3 lanes when it is close to 2? Why don't I round off? If I round off, if you round off 2.09, it will be 2 or 3.
But I'm using the maximum factors for that to find the. Hold a second.
You hold a second. Okay. 2.39 is the minimum you need for level of service C. Can you go less than minimum? You cannot. Okay. Simple. Okay. This is the minimum number of lanes you need for level of service C. If you go less than that, you will not have level of service C. Clear? Okay. There is something which is written in the question that you can go up to level of service D as well. Somebody may say, okay, let me provide 2 lanes only. Instead of C, I will have D, which is acceptable, right? In the question they are saying it is acceptable. But that also means what? You don't have any margin now. Okay? If traffic increases little bit, it may go from D to E. But if you provide 3 lanes here, you only need 2 point something, right? If you provide 3 lanes, maybe the actual level of service is better than C. Okay, you are providing more than required, right? So your actual level service may be more than C. And even if the traffic increases little bit, you will go to C or maybe D, not E. Got it? Okay. Okay, this is the last example in this chapter. Okay, and it's still about a freeway. We have 6-lane freeway. Free flow speed is given. Rolling terrain, traffic has 10% trucks. Other conditions, standard conditions apply. So no adjustment factors. Peak hour factor 0.92. Current volume is 3,600 in one direction. They are expecting 6% growth every year for the next 20 years. Okay, from now onwards for the next 20 years, traffic is increasing by 6% every year. Okay, so now they are asking what is the level of service now, what is the level of service after 5 years, 10 years, 15 years and 20 years. Okay, so it's the same calculation but we have to do it for multiple years. Got it? Okay, what we did yesterday for finding out level of service, you can repeat the same thing here as well. Okay, what will change? Only the volume. Every year the volume will change, right? Nothing else. Okay, so let us calculate what will be the volume after the number of years for which they are asking for. If traffic increases 6% 1 year, then how much after 5 years? My traffic is 3,600. It increases by 6% every year. So how much will it increase after 5 years?
5 times 600 times 600.
5 times, right? 5 times 6. 5 times 6, 30%, right? Okay. This is valid if the initial value remains the same for all the years. Okay. Traffic now is 3,600. Next year it will not be 3,600. Okay. So every year traffic is increasing and the 6% is of the new value, not 3,600. So year 2, the value is not 3,600. There is not 6% of 3,600. It's 6% of the value of year 1. Okay. So in the 5th year, it will be the value 6% of value in year 4. Okay. So you cannot just multiply 6% by 5. Okay. So we use an equation which is the growth rate equation, which yes, F value. Okay. Where n is the number of years. Okay, so we call it compounding growth rate. So when the initial value changes every year and you are applying the same growth rate, then this is how we calculate the future value. Okay, so what will be the value after 5 years, 10 years, 15 years and 20 years? Give me. We just change the n value. 4818.6. Okay. Next.
6447.
6447. Next.
8627.
8627.
1154.
54. 5.
1154.
545. Okay, so these are the values. Okay, you take these values, find out the level of service like we did in the previous example, not today, yesterday. Okay, so you will do the same thing 5 times. One with using 3,600, the other time using this value, the other time using this value, then this value, then this value. Okay, clear or not? Okay, now there is a shortcut to this problem. In this shortcut, you can use the maximum service for it. I can apply it because the free flow speed is 65. For speed of 65, I don't have to draw the curve. For a speed of 65, the maximum service for it is already given. Okay, is given here. So when the speed is 65, this much is for level of service A, then for B and the C and so on. Okay, so these values are given. So since I don't have to plot the curve, I can apply this method as well. Okay. Now you see these values, their units are vehicles per hour. Okay. When you take the value from the curve, their units are passenger cars per hour per lane. Okay. The units are passenger cars per hour per lane. Okay. So the only thing which I have to do is do the conversion, and then I can compare between them. Okay. So for example, I need the FHV factor now.
1/1
My percentage, what is the percentage of flux?
0.1.
0.1. What terrain we have?
Rolling.
Rolling. Okay, for rolling terrain the factor is this 3. Okay, how much is this? 8? 3? Okay. So what we will do is, all these values will be divided by 0.83 and the peak hour factor. Okay, all these values will be divided by 0.83 and the peak hour factor. So 3600 divided by 0.83. What is the peak hour factor? 0.9. How much? Sure? We didn't add the number of lanes, sorry. Number of lanes as well, it's per lane. So 3 lanes. Divided by 3, how much? 1571. Okay, now you see this value, 1571, right? Okay, if I come here, the maximum flow rate of A is 710. So I'm more than maximum, right? Okay, the maximum for B is 11 something. More, right? I don't have B. Maximum for C is 1560. It's still more, right? Maximum for D is this much. So I'm here, right? I'm between these two. Okay, so my level of service is D. Okay, so air 0, current air, the level of service is D. Okay, next air, how much? The value is 4818. What is my level of service? Do I still have D? No, I've crossed D, right? Okay, so now I have E. Okay, next one. Now I will divide everything by, I will divide 6447 with the same factors. How much? 2814. Okay, what level of service I have? Do I still have D? No, I've crossed the D, right? I've crossed E, right? So my level of service is F. Clear? Clear? And after that the value is increasing, right? So it will still remain F. After E is F, right? So it will still remain F. Okay, so this was air 0, this was air 5, this was air 10. So between these two airs I achieved level of service F. Clear? Now somebody wants to know in which air exactly I achieved level of service F. Okay, when did I achieve F? When I crossed this value, right? When I crossed the last value, my level of service became F. Okay, I can go back to this equation and find out my airs in which I got level of service F. Okay, so The value I'm looking for, the future value is 2350. My present value is this one after conversion. Okay, 1571. Okay, so this was the current value. When the current value becomes this much, my level of service is F. So in how many years it became level of service F? The N value, how much is it? Cannot be 0. Now you see this is between year 5 and 10. Okay, the answer is between year 5 and year 10, right? This was at year 5, this is at year 10. The answer is between them. How much? Cannot be. How is this possible? Oh, sorry. Now tell me. 6. How much? 6.9. Okay. In 6.9 years, the level of service becomes F. I will reach the last point of E. After it will become F. Okay. Some points here which I mentioned, it has nothing to do with the calculations. If the level of service F becomes F, what you can do? You can build another highway, increase the number of lanes. Okay. You can do some changes in the area. These changes are called zoning regulations. So if there is high-rise building in the area, you tell them no high-rise building. If there is mall in the area, you remove the mall, and so on. These are called as zoning regulations. You make the changes in the area. Increase public transportation. So people go from cars to buses. Okay. Build other highways. So people, instead of using this highway, go to those highways. Okay. And the last one is change the working hours in the area. Okay. When there is peak hour means what? All offices are starting at the same time, right? So when you distribute the time, people from different offices will come at different times. Okay. So they call them staggered working hours. Okay. So all these strategies can be applied to reduce or to avoid level of service F.
So I have a request. Can I go?
Yes.
Me also.
Yes. Okay, some practice problems. Have a look at them. Even if you look at the problems which are in the slides, you will see each one of them is different. Okay, so you need a lot of practice for that. And all of them are very long examples. Okay, if you need a lot of practice, please do that. Okay, thank you.